Okay, hi everyone. In this video, I'll be going through chapter 6, worksheet 1, how to find gradient of a straight line. Okay, given the coordinates of 2 points on the line. So very simple, let's recap what you have learned before. Okay, so you should have seen these two basic things we call this the Cartesian coordinate system. What this means is that we have learned that this horizontal line here is called your x-axis. We label this by x. This vertical line here is called your y-axis. We label this with a y. So any point, let's say a point over here, okay, in order to write the coordinates, we always check what is the x coordinate first. So I'll draw the horizontal vertical line down to your x-axis here. Let's say this a value of x is a. Then at this point here, I do a horizontal line to check what is the y value, and this y value here is b. The coordinate is simply a comma b. We always write your x coordinate first, then your y coordinate. So very simply, this is how the Cartesian coordinate system works, how to identify points on this Cartesian plane. Okay, so we can now look at the next part. We have also learned before that in this kind of Cartesian plane system, we have also learned how to find gradient of a line. So let's say if I have this line over here, okay, in order to find gradient, the formula is simply the vertical change over the horizontal change. Meaning, for example, if I consider for this line over here, I take 2 points, let's say A and B. Okay, A and B here, A has the point -1, 4, which means that the x coordinate here is -1, the y coordinate is 4, and for point B over here, x coordinate is 6, y coordinate is -2. X coordinate here is 6, y coordinate here is -2. Okay, in order to find gradient, it is the vertical change over horizontal change. So for this one here, very simply, gradient of this line, gradient of line AB is simply vertical change, which means from A to B, what is the vertical change? So you can see that at first the y value is 4, now the y value become -2. So to find the vertical change, this is -6 units. Okay, -6 units. And the horizontal change from A to B, the horizontal change in my x-axis value here is from -1 here to 6. So the vertical change is actually 7 units. This entire thing here is 7 units different. So therefore, that is simply your gradient of line AB. Okay, so this is a very quick recap of what you have learned in terms of gradient. How do we find gradient of line AB? Okay, so now, if you look at the integral formula, let's say if instead of AB, I don't know what is the number here, I call point A x1, y1, and point B is x2, y2. The formula you just need to know is simply gradient. We can also represent gradient using a letter M equals to the y coordinate here, y2 minus away y1, okay, over x2, which is your b coordinate here, minus away x1. Okay, so if I have a straight line like this, as long as I know 2 points, I can find gradient already. Okay, so you just need 2 points to find the gradient of the straight line. Okay, so just to take note, you can remember as y2 minus y1 over x2 minus x1. You can also remember as y1 minus y2 over x1 minus x2. I find remembering this is easier because it's 2 than 1. Okay, and in this case over here, both formulas will also work. Okay, and take note that your x coordinate here cannot be the same. If they are the same, it means that x1 is equal to x2. Your denominator of this fraction will become 0, and the fraction will become undefined, which means we cannot find any value for a fraction whereby the denominator is equal to 0. Okay, so some simple questions over here. Why is y2 minus y1 over x2 minus x1 the same as y1 minus y2 over x1 minus x2? Okay, very simply, if you do simple algebraic manipulation to find gradient, why are these two the same? Is because, let's say if I were to write y1 minus y2 over x1 minus x2, if I were to factorize out a negative from both my numerator and denominator, let's look at my numerator first. If I factorize out a negative sign, this will become y2 minus y1 Okay, denominator I also factorize out a negative sign. Factorize out negative sign. X1 will become negative x1. Negative x2 will become positive x2. And this will become x2 minus x1. Okay, and this negative 1 on my numerator and denominator can cancel out. Therefore, this is the same as y2 minus y1 over x2 minus x1. Okay, so remember these two are the same. Okay, and therefore, for a straight line, the question is asking you for this straight line like this, why is the gradient of the straight line always the same? No matter I take any 2 points on the line, I find a gradient. I take A and B, I find a gradient. It is always the same. The question here is, why is the gradient always the same on the same line? Okay, so one important point to note is that on a straight line, please write this down to your worksheet. On a straight line, gradient is always constant. Is always constant. Okay, as long as you have a straight line like this, as what we have seen earlier, the gradient is always constant. Okay, so types of gradient in a straight line graph. Straight line graph can be upward sloping, means that from left to right, the graph is going upwards. It can also be a horizontal line like this, or a downward slope whereby from left to right is going downwards. Okay, so if it's going upwards, we call this a positive gradient. If it's a straight line, a horizontal line, the gradient is 0. Remember, gradient means how steep the line is. If it's a straight line that is not steep at all, gradient is 0. And if it's a downward sloping line, the gradient will be negative. Okay, so and if a line is vertical, the gradient is called undefined. Or if you were to take your y2 minus y1 over x2 minus x1. Okay, remember this is the formula for gradient. Gradient is given by this formula over here. Okay, if the gradient is undefined, it means that your x2 over, if I consider any 2 points on this line, x2 minus x1, this x value is the same because it cuts the same, it has the same x value on your x-axis. This denominator is equal to 0. That is why the gradient is undefined. Okay, so let's now look at the next part here. We can go directly now to okay, before that, maybe just some important things to note. This is called your y-intercept, the part of the graph which cuts your y-axis, and the parts of the line that cuts the x-axis here. This part here is called your x-intercept, this point here. Okay, let's now look at example 1, very simple example. Find the gradient of these 2 points, of the line passing through these 2 points. I'll write out the gradient formula here first, so you can also write that down with me. Gradient is given by the formula y2 minus y1 over x2 minus x1. Okay, so let's now look at example 1a. Find the gradient of the line passing through these 2 points. So therefore, to find the gradient of the line, gradient of line AB, I take y2 minus y1, which means that, let's say I mini label this. This is A, I can call this x1 comma y1. This point B here, I can call this x coordinate 2, y coordinate 2. Okay, so by the formula here, okay, y2 is 3 minus y1. 3 minus away negative 1. Take note, this is a minus, then minus away negative 1. Same thing over here. X2 is 1 minus away negative 2. 1 minus away negative 2. Okay, then I simply evaluate this. This is 3. Negative times negative 1 will give me 3 plus 1 over 1 plus 2. Final answer is simply 4 over 3. Okay, this is for part A. Okay, you can now try the same thing for part B, C, and D. And pause this video here first. Then once you have done, you can continue playing this video to check back. Okay, I'll work out this part over here first. Part B, gradient of line HK equals to negative 3 y2 minus y1 minus 2 over 2 minus negative 3. Okay, to highlight, to make it clear, y2 here minus away y1, which is 2. Then x2 here minus away x1. Okay? So let's evaluate this. This is simply negative 5 over 5. Therefore, answer is negative 1. This is for part B. Okay? Let's now look at part C. Part C over here, gradient of line MN. Gradient of line MN. Okay? This is simply equals to y2 minus y1. y2 is negative 2 minus negative 2. Okay? Then y1 is simply 4 minus away negative 3. Okay? So from here, if you were to simplify this, this should be equals to negative 2 plus 2 divided by 4 plus 7. Negative 2 plus 2 is 0 divided by 11. Anything with the numerator is equal to 0 is simply equals to 0. Okay? This is for part C. Then for the last part here, part D. Okay, part D, gradient of line PQ. PQ. Okay, this is negative 4 minus away 6 over 3 minus 3. And I'll get negative 10 divided by 0. So for this part here, take note, since denominator is 0, this means that the gradient here, gradient is undefined. We cannot divide anything by 0. So in this case over here, the denominator can never be 0. So therefore, this would mean that the gradient is undefined. Okay? If you don't believe, you can also press your calculator. Any number divided by 0, you should get a math error because the value is undefined. Okay? So from this example, we can conclude that gradient of line rising from left to right is simply positive. Gradient of line falling from left to right is a negative gradient. Gradient of horizontal line means that there's no steepness at all. It is equal to 0. Or maybe I write the word down, 0. Okay. Then a gradient of a vertical line is undefined. Okay. Okay, if you're able to follow, can you now try this part by yourself? Very simple questions to ask you to find out what is the gradient of these lines here. All you need to do is apply the formulas. Okay, so formula again, I write over here. Gradient is equal to y2 minus y1 over x2 minus x1. Okay? Then from here, you can calculate out all these gradients. Okay, so I will you can pause this video here first. Okay, finish up these questions, then continue playing this video to go through these answers, okay? So very quickly, I'll just work out all the solutions. Gradient of AB, y2 minus y1, 2 minus negative 4 over 3 minus 1. This should give me 6 divided by 2, 3. Okay, so it asks you to draw a sketch in the box. So therefore, this first line, positive gradient, it is a rising graph, so upward sloping graph. Okay. Next one, gradient of line AB. It simply equals to 3 minus 3 over negative 3 minus 2. I should get 0. There we see no reason if gradient is 0. If gradient is 0, this means it's a horizontal line. Your graph should look like this. Okay. Then next one, if gradient of line KL, gradient is simply equals to y2 minus y1, negative 2 minus 2 over 2 minus negative 3. Okay. This should be negative 4 divided by 5, negative 4 over 5. So we can check again. If gradient is negative, This means it is a falling graph or downward sloping graph. Your graph should look like this. Okay. Okay, moving forward. Gradient equals to y2 minus y1, 4 minus -1, divided by -4 minus -4. In this case here, denominator becomes 0. This is undefined. Undefined means your graph is a vertical line. Okay. Next one, gradient equals to 1 minus 3 over 2 minus -2. Okay, calculate this. This should give me -2 divided by 4, -half. Negative gradient, downward sloping graph. Next one, gradient y2 minus y1, 5 minus 10 over 1 minus 4. I should get -5 divided by -3. I'll get 5 over 3. Positive gradient, upward sloping graph. Okay, this is for this part here. RS gradient simply equals to 2 minus 2 over 7 minus 0. I should get 0. Okay, a gradient of 0 means that this is a horizontal line. Next one, gradient equals to 8 minus -4 divided by -1 minus -1. You should get undefined. The denominator is 0. Undefined means this is a vertical line. Okay, then last one, gradient is simply 8 minus 12 over 3 minus -1. Okay, and this should be 4 divided by, -4 divided by 4. I should get -1, negative gradient, downward sloping graph. Okay, and this is for this try yourself question. Okay, now let's move on to example 1. Very simple. Okay, use gradient to determine the coordinates of a point on the line. So the question here says, if the gradient joining the points, these 2 points here is -4, find the value of p. We write down the formula for gradient first. We know that gradient is equal to y2 minus y1 over x2 minus x1. Okay, so if I have 2 points here, 2 points, I can now find the gradient. So this means that if I were to write my y2 minus y1, my y2 is simply, y2 I highlight, y2 is 7, this is y2. My x2 is p. My y1 is p. My x1 here is 2. Okay, so if I find it hard to visualize, I can write this down in small size for you. I can see this as x1 comma y1. This is x2 comma y2. Okay, so therefore, if I were to find gradient, this means that 7 minus y2 minus y1, 7 minus p over p minus 2, x2 minus x1 is equal to -4. Okay, this is what the question is saying. Okay, so therefore, very simply over here, how to solve this algebraic equation? Get rid of fraction on both sides by cross multiplying. So if I were to cross multiply, means I cross upwards. Okay, -4 is -4 over 1. This will give me 7 minus p equals to -4 plus 8. Okay, -4p, sorry. -4 times this whole thing. Okay, let me write it to be clearer. -4 times p minus 2. Okay, expand out the bracket. 7 minus p equals to -4p plus 8. Okay, then now to find p, I make p the subject of the equation. Shift all terms with p to the left side. This will become -p plus 4p. Right side will become 8 minus 7. Therefore, 3p is equal to 1. Therefore, I want to find out what is p. Divide both sides by 3. P is equal to 1 over 3. Okay, and this is for example 2. Okay, let's now look at example 3. Example 3 here, they say that these 3 points lie on a straight line. Remember, on the straight line, the gradient is always the same. So no matter which 2 points I take, the gradient is always the same. So we can know that gradient of line P of PQ is the same as Q to R, and is the same as P to R. Okay, so over here, what we can do first is to find the gradient of this straight line. I can use PQ here. Okay, PQ here to find the gradient of this line PQ. Let's do it step by step. So, gradient of PQ. PQ got no unknown, so very easy to calculate. What is the gradient? Okay, we can use y2 minus y1, negative 2 minus negative 3 over 3 minus 2. Okay, then I calculate this. This is negative 2 plus 3 over 3 minus 2 is 1. Therefore, negative 2 plus 3 is simply equals to 1. Okay, so therefore, gradient of line PQ is equal to 1. Then, now let's say I want to now make use of this unknown point over here. So I can write that gradient of, let's say, make this easier, I say PR, okay, is equal to z minus negative 3 over 8 minus 2. I'm looking at these two coordinates now. y2 minus y1 is z minus negative 3 over 8 minus 2. Okay, then I simplify this. This will give me z plus 3 over 6. Okay, so therefore, since they lie on the same straight line, this means that the gradient is the same. So therefore, this means that z plus 3, the whole thing divided by 6, is equal to the gradient here, which is 1. So from here, I can easily now solve for z. I have a fraction on both sides of the equal sign. I can cross multiply first. Cross multiply upwards. This 1 can be seen as 1 over 1. I'll get z plus 3 equals to 1 times 6, which is 6. Therefore, z equals to 3. And that's your answer to example 3. Okay. Alright, let's now look at the last example for this worksheet. Okay, a line passes through these 2 points over here. Find the gradient of this PR. You should know by now how to find gradient of a line given 2 points. To find gradient, simply use the formula y2 minus y1. y2 will be 6 minus negative 4. 6 minus negative 4. The whole thing divided by, now I look at the next one, x2 minus x1. 5 minus negative 3. 5 minus negative 3. Okay, then from here I work out this solution. 6 plus 4 divided by 5 plus 3. I'll get 10 over 8, which can be simplified to 5 over 4. This is for example 4a. Okay, then the last one. Given that another point lies on the same line, find the value of k. If they lie on the same line, it means that if I take this point and another point and I find the gradient should be equal to 5 over 4. So let's choose any point. Let's say I choose P and Q. Okay? I find the gradient of PQ. Gradient of PQ. I can apply the formula. Let's say Q is y2 minus y1. K minus negative 4. Let's write it down. K minus negative 4 over x2 minus x1, which is 1 minus negative 3. 1 minus negative 3. Okay. Then from here, I continue to work out. Simplify this. K plus 4 over 1 plus 3, which is 4. Okay. And therefore, this means that since it lie on the same line, it means that K plus 4 over 4, the gradient of line PQ, is the same as the gradient of line PR, 5 over 4. Then from here, simply cross multiply to solve this equation. I can cross multiply upwards. This will be 4 times k plus 4 equals to 5 times 4. Okay, so expand and simplify. 4k plus 16 is equal to 20. Therefore, 4k equals to 20 minus 16, which is equal to 4. K, therefore, equals to 1. Okay, and that will be the end of this worksheet. You can start on the homework questions from here already. Okay, and that's the end of this video.